Let's take a look at writing equations of lines in point-slope form. A line with a slope m containing the point x1, y1 can be written in the form y minus y1 is equal to m times x minus x1. Let's use this formula to write the equation of the line with m equals negative 5 over 4 containing the point 8, 6. We'll write y minus 6 is equal to negative 5 over 4 times x minus 8. This is an equation of a line, but it really doesn't give us much information. So let's rewrite it in slope-intercept form so that we can see what the y-intercept is and so we could easily graph it if we chose to. So we can leave y minus 6, but I want to distribute the negative 5 over 4. I have negative 5 over 4x. A negative times a negative is a positive, so I have 5 over 4 times 8. Continuing, I have y minus 6 is negative 5 over 4x. Plus, I can cancel the 4 into the 8 2 times 5 is 10. Let's bring the 6 over so that I have y is equal to negative 5 over 4x plus 16. Let's try that again, but this time we want to write the equation of the line containing the point 7, 3 and 5, 9. We want to start by thinking we need the slope of the line. So the slope is going to be equal to 9 minus 3, the difference in the y's, over 5 minus 7, which is the difference of the x's. In the numerator, 9 minus 3 is 6. In the denominator, 5 minus 7 is negative 2. We can simplify that to a slope of negative 3. Now that we have the slope, let's work on making our equation. I'm going to do y minus. You can pick either of the points, 7, 3 or 5, 9. To do your equation, I'm going to use 7, 3, so I'm going to have y minus 3 is equal to negative 3 times x minus 7. Y minus 3 then is equal to, I distribute this negative 3, which gives me negative 3x plus 21. I'm going to move the 3 to the right side, so now I have y equals negative 3x plus 24. This one says write the equation of the line with an x-intercept at 7 and a y-intercept at 9. Even though it's stated differently, this is very similar to our last example of having 2 points and coming up with the equation of the line. Here, I have the x-intercept is 7, so that says I have 7, 0. And then the y-intercept of 9 says we have 0, 9. So I have 2 points. Let's come up with the slope. The slope is the change in y, 9 minus 0, over the change in x, 0 minus 7. 9 minus 0 is 9, 0 minus 7 is negative 7. I have a slope of negative 9 over 7. At this point, I have 2 choices. I can use the point-slope form of a line. I can use slope-intercept. This time, I'm going to use slope-intercept, which is y equals mx plus b. I have the slope, negative 9 over 7. I have the y-intercept, 0, 9. We can write y is equal to negative 9 over 7 times x plus the y-intercept of 9. Our last one says find the x and y-intercepts of the line with slope equals 1/5 containing the point 3, 4. So let's talk about strategy. The strategy I'm going to use is come up with the equation of the line, take that line, write it in slope-intercept form. I'll easily see the y-intercept. After I have the y-intercept, I can go back to the line, plug in y equals 0, and find the x-intercept. So let's start by coming up with the equation of the line. I have y minus 4 is equal to 1/5 of x minus 3. I have y minus 4 is 1/5 of x minus 3 over 5. I'm going to bring the 4 over. I have y equals 1/5 of x. 4 can be written into a fraction with the common denominator of 5, so 4 times 5 is 20 over 5. So when I add negative 3 over 5 to 20 over 5, that gives me a positive 17 over 5. So this is the equation of the line. Immediately, I can tell that the y-intercept is equal to 0, 17 over 5. So I've answered half of the question. The second part of the question says find the x-intercept. So to get the x-intercept, y would be equal to 0. So let's write that x-intercept, y equals 0. So we're going to say 0 is equal to 1/5 of x plus 17 over 5. Let's move the 17 over 5 to the left. Now we have negative 17 over 5 is equal to 1/5 of x. To clear the 1/5, I'll multiply both sides by 5. All the 5's cancel. I have negative 17 equals x. So my x-intercept is negative 17, 0. What I think we should do is verify our result by graphing. So I'm going to graph y equals 1/5 of x plus 17 over 5, and I'm going to use a graphing calculator to do that. Once I graph it, I'll make sure my original point, 3, 4, is on the graph, and we already know it has a slope of 1/5, but we'll be able to see it. I'm going to check my intercepts, so those two numbers I just found, negative 17, 0, and 0, 17 over 5, I want to make sure those show up the way I expect them to. I'm going to graph in Desmos. I'm going to go to the first entry, and I'm going to write my line y equals 1/5 of x plus 17 over 5. So it graphed the line for me. Now what I want to do is verify that my original point is on that line, so I'm going to go into the second line of Desmos and put in 3, 4. You can see that it is a point on the line. It shows up, and we could have it label it. What I also want to do is verify the intercepts. So we said our intercepts were 0, 17 over 5. So I'm going to put that in so I can see it on the graph, and let's label it. And we said our x-intercept was negative 17, 0. So let's put that in and also say label. Love Desmos for this, to be able to give us that verification that we did things right and to graph it very nicely, because graphs sometimes are hard to do without technology. I hope this helps you understand how to write equations in point-slope form, and I hope you also see that once we're in point-slope, we're going to go back to slope-intercept to get more information and be able to graph really easily.